Hey y'all, we are Memphis University and we're back for another Calculus Done Wrong lesson where we run calculus before calculus wrongs us. And today we're going to be continuing our advanced derivative topics unit and we're going to be talking about MVT and IVT. So MVT and IVT is a very strange lesson because these theorems, MVT stands for mean value theorem, IVT stands for intermediate value theorem. Both of these theorems are existence theorems. So they don't actually find you answers like normal. It's not like just take the derivative, plug in the number, or take an integral, find this number, or something like that. What these questions do, they tell you that an answer exists. So for example, in IVT would just tell you that the function equals a number somewhere in an interval. It doesn't tell you what number it actually equals, but it just tells you that it will equal somewhere. So we have to be satisfied that at least we know that there's an answer. Same thing with MVT. MVT will show you that a derivative equals a number somewhere, but it won't tell you at what number that derivative equals that number. But they are still very useful. They are theorems that prove other theorems, and they do appear on the AP exam, usually in the form of tables, so we are going to rely a lot on tables as we do our examples. But to start off with, let's just state what the theorems are, and then we'll sort of work with some function questions, and then we'll go for those table questions, which again are more frequently found on the AP exam, especially in the free response question on the tabular frick. So let's get started. Let's do IVT, MVT. So first off, I'm going to just draw an example of one and then state the theorem. So the first one we're going to do is let's do intermediate value theorem first. So IVT stands for intermediate value theorem. If I can spell the word intermediate value theorem. So I'm going to draw a picture first because it makes more sense with a picture. Let's say we have a point A and B. So these are just two arbitrary points. We have function values like, let's say f of A is right here and f of B. So we have this sort of line. We have this point right here and this point right here. And the intermediate value theorem, so this function looks like this. This is my f of x. What it says is that for any number in between f of b and f of a, it doesn't matter if f of a or f of b is which one is bigger, but if you have any number in between here, let's just call it n, then there's going to be some x value in between a and b, we're going to call that c, where f of c equals the number. And you can sort of see that this is obvious. If you're going to have a number in between, there's going to be some x value that reaches that value. The important thing is that you need the function to be continuous because you might be able to jump if you didn't have this situation. But the actual wording of the question or the intermediate value theorem is if a function is continuous, and we have this situation, the number is inside f of b and f of a, so n is in between f of a and f of b. Then there's some c in the interval, so there is some c, but we're never going to be able to find c, but there are just some c in between a and b. So it's within this interval a and b, such that f of c is equal to n. So another way to say this is that for any intermediate value, so that's why it's called the intermediate value theorem, for any intermediate value between f of a and f of b, that value is achieved by the function at some point c. You don't know what it is, but it is achieved. So for example, let's say we have numbers 2 and 7, just as an example. So our we have 2 and 7, then for any y value in between 2 and 7, for example 5, I will be able to find a c such that f of c is equal to 5, where c is in between this interval. So again, it's not really saying much, and it's also very logical. It seems like, well, obviously this is true because you have a continuous line, you don't lift with your pencil. So any value in between will get mapped to eventually by the function because there's no way to draw this without sort of crossing things. But that's what the intermediate value theorem says. So the more important thing is how do you employ the intermediate value theorem? It's actually a lot of not very much work. When sometimes students do this, they feel like they're not doing enough work in this question, but it doesn't require a lot of work. All we're going to do is we're going to show that the number we care about is in between the function values of the endpoints of the interval. And that's all we're going to do. We're going to just say like 5 is in between 2 and 7, and we're just going to be good to go. we're going to write the theorem out as we practice these examples. So you're going to get some sort of sense on how to do this. But again, the work isn't really difficult. All we're going to do is say that a number is in between certain values, and that's all it is. So that's intermediate value theorem. Let's try to state mean value theorem, and then we'll go for examples. So I'm going to erase this. So now we're going to do mean value theorem. So MVT, which stands for mean value theorem. So in this one, what you need is you need the function to be differentiable. But again, let's start off with a picture. So basically what it says is if you have A and B, and you have this function, let's try to draw this again. Let's say we have f of A right here, f of B, and we have like this guy right here, something like this. What mean value theorem says, mean refers to the slope. What it says is that the slope between, along the line containing A and f of A and B and f of A, that's going to be equal to the slope somewhere in the interval instantaneously, meaning the derivative. So the slope of this line right here, which is found using algebra slope, just y2 minus 1 over x2 minus x1, that slope is going to be equal to the slope of the tangent line somewhere along the curve of f of x. So in this case, there actually is going to be 2, but we only care about this. As long as there's 1, we're good to go. So notice that these two lines are parallel. So this bottom line is given by the line between these 2 points, so its slope is determined by algebra. The second line is a tangent line. It's touching the curve only at one point. They do share the same line, but this line's the top line. That derivative is that slope is given by the derivative, because remember, for tangent lines you need a point and a slope where the slope is the derivative. So notice that these two lines are parallel, so that means that their slopes are the same. So that's all it's saying. What it's saying is that somewhere in the curve, somewhere in the interval along the curve f of x, the slope at a specific point instantaneously, only at that point, will equal the slope over the entire interval. So the way I like to think about it is the phrase calculus slope equals algebra slope somewhere in the interval. Again, you don't know exactly what point it actually is, but we're going to be satisfied with just knowing that a certain answer exists. So the actual statement of the theorem is that you need a function to be differentiable. So f is differentiable. And why you need differentiable, remember that differentiable means that you can just take a derivative, and you need to be able to take a derivative in order to have this sort of process. So what it says is that I like to remember it as calculus slope equals algebra slope. Somewhere in the interval, but more precisely what it says is that there is some c. Again, you're not going to be able to find the c, you just need to know that it exists. So in this case, the c would be around right here, but I wouldn't be able to find it. But the important thing about the c is that the derivative of the function at c is equal to the algebra slope over the entire interval. So there is some c where c is in this interval, where, let's actually use parentheses because c has to be strictly within the interval, where f prime of c equals the algebra slope. And remember that algebra slope again is just y2 minus y1 over x2 minus x1. So this is what MVT says. Somewhere in the interval, calculus slope equals algebra slope. So those are the two theorems, IVT or MVT. First off, you need to be able to do a few things before you start doing these questions. So the first thing is to recognize an MVT or IVT question. And what I tell my students is that the wording is a little bit weird, because again, these are existence theorems, so they don't tell you answers. So the wording of these questions isn't going to be something like find this number, or take this derivative, or take this integral. It's going to be a little bit weirder than that. It's going to be something like show why this must exist, but you don't have to actually find it, or why must this happen, or what's the fewest number of times that this situation arises. So the wording is a little bit weirder, and on these free response questions, you're going to be able to recognize, oh, this is an IVT or MVT question, because they don't actually want me to find the answer, they just want me to show you that the answer exists. And usually on these free response questions, the answer is always true. So if they say, must this be true or something like that, the answer is true, and it's either by MVT or IVT. So that's the first thing, trying to recognize that it's an MVT or IVT question. The second thing you have to recognize is whether to do MVT or IVT. The general rule of thumb, because MVT has calculus slope equals the algebra slope, whereas IVT was just saying that the function value is in between the function values of the endpoints. If it's a derivative, you use MVT, and if it's a function, you use IVT. That's just a general rule of thumb that usually works to 80% of the 90% of time. So again, if they say like show that f of c equals a number, that's probably IVT because there's no derivative. And if they say f prime of c equals a number, that's probably MVT. Then after you try to decide which one to do, IVT or MVT, you have to do that process for the respective one. So for example, for IVT, what we're going to do is we're going to show that the y value is in between. And for MVT, what we're going to do is we're going to show that the number they want is exactly the algebra slope. So that means the calculus slope will equal the algebra slope somewhere in the interval. So IVT is all about in-betweenness. MVT is all about calculus slope equals algebra slope, where the algebra slope is the number you want. But again, these are pretty theoretical questions, even if they're not the hardest questions in my opinion. So the best way to do this is through examples. Let's try to do some examples. So let's see here. So the first few we're going to do, again, are going to be more equation-y based. And then later on, we're going to do some that involve tables, because usually they're asked with tables. So imagine we have this function right here. F of x equals, copying this off my computer screen, 2x cubed minus 2x squared minus x minus 4. And what we want to do is we want to show that this function has a root in the interval, let's say -1 and 2, -1 and 3. So this is going to be my question. So what I'm trying to do is I don't have a calculator with me. I want to know if this function has a root, meaning it crosses the x-axis somewhere in between x is equal to -1 and x equals 3. So another way to phrase this is that we want to show that somewhere f of x equals 0 for some c. So first off, we recognize that it's an MVT or IVT question because again, we're not actually finding the root, we're just showing that it has a root. Secondly, we have to decide between IVT or MVT, but because this is a function equals a number as opposed to a derivative equals a number, it's probably going to be IVT. So let's start our first IVT question. So the way it works, again, people get kind of confused because you don't do much work, but all you're going to do is you're going to plug in -1 into this function, that's the left endpoint. Then you plug in 3 into this function, that's the right endpoint. And what you're hoping is that 0 is in between these two numbers. As long as 0 is in between these two numbers, then you're good to go, you'll write a sentence. So let's first find these two numbers. So we're gonna first find f of -1. This is a little bit of work on the side. So it's gonna be 2 times -1. Let's try to be a little bit more careful. Minus 2 times -1. So I'm just plugging in -1. Again, it's just basically algebra. So it looks like we're going to have, if I can do this math correctly, -2 plus 2, that will go away. Oh, this is squared though, so it won't go away. -2 minus 4 minus another 4 minus 8 plus 1, I believe you have -7. Then we're going to do the same thing with f of 3. So all I'm doing is plugging in the endpoints into our function. That's how you do IVT. So you're going to do 2 times 3 cubed minus 2 times 3 squared minus 3 minus 4. Just plugging in -1, plugging in 3. So when we plug this in, this is going to be kind of big, but we can do this work on the side. 27 times 2 is 54. 54 minus 9 times 2, that's 18. 54 minus 18, I believe, is 36, probably. 36 minus 7 is 29. So here we go. So again, to start off an IVT question, just plug in your endpoints. And what you need to do is you need to make sure that the y value you want is in between these two numbers. And notice that 0 is in between -7 and 29. And that's all the work. We're done. Again, people get confused because they're like, I didn't really do much. But that's all you have to do. To finish the question off, you just have to write a sentence. So when I write a sentence, I always start either by IVT or MVT, depending on what we're choosing. So by IVT. And the way IVT works is that you want to say that your y value is in between the y values of the endpoints. So because 0 is in between f of -1, which is equal to -7, and f of 3, which is equal to 29, by IVT, there exists. I like to just repeat their question, but there exists a C in between this interval, -1 and 3, such that f of c equals 0. And that's how it works. So again, let's go through over the steps here. We know that it's an IVT or MVT question because it's a little bit weird. Show that f of x has a root. Don't find the number, just show that it exists. So it must be MVT or IVT. Because we want to show that f is equal to a number as opposed to a derivative equals a number, we're going to do IVT. In order to employ IVT, all you do is you plug in the endpoints and you hope that your y value is in between, and it needs to be in between. So the most important thing is probably the sentence. So let me go over the sentence. It's either by IVT, then we write the justification. So the justification is 0 is in between these y values that we found. So 0 is in between f of -1 and f of 3 because they're -7 and 9. Then you just state the theorem. There does exist a c between -1 and 3 such that f of c equals 0. So what we know about this is that there's some number in between -1 and 3. I don't know what it is, but f of that number is equal to 0. And that's IVT. So now what we're going to do is we're going to do a similar example with MVT. So let's erase this. So let's do this. Let's say we have a new function. X is equal to be x squared minus 3x. And what we're going to do is we're going to try to prove that f prime of c equals -1 for some c in between x is equal to -1 and 3. Keep in mind that coincidentally these two questions both involve -1 and 3, but that's a coincidence. Furthermore, we're not just going to do this question. Always nice to do a little bit of a double. We're going to find the c at the very end. So let's try that. So let me make a nice little line. So when I'm confronted with this question, I think about, well, it looks like I need to prove that something exists, but I don't actually have to find the number until later. So that's MVT or IVT. So this first sentence is going to be MVT or IVT. Then you have to decide which one you want to do. And remember that because it's a derivative equals a number as opposed to the previous question, which is equal to a function equals a number, it's probably going to be MVT. Because MVT is remembered by the phrase calculus slope equals algebra slope. So that's like how I actually like to do my MVT questions. I like to write by MVT. And what I do is I just start immediately doing algebra slope, where algebra slope is y2 minus y1 over x2 minus x1. So it's going to be f of 3 minus f of -1 over 3 minus -1. This shouldn't be too bad. When you plug in 3, it looks like it's going to be 3 times 3 is 9. 9 minus 9 is 0, so it can be 0. Then when you plug in -1, -1 squared is 1. Minus 3 times -1, that's going to be 4. 1 plus 3. So it's going to be minus 4 over 4. And notice that this is -1, the number we want. F prime of c equals -1. Keep in mind that in IVT, all you're doing is showing the y values in between. But for MVT, you need this algebra slope to be exactly the number you want in calculus slope. And that's basically all the work you're doing when you're doing the proof the MVT. Again, it's not that, there's not a lot of work required. All you're doing is you're basically finding algebra slope and verifying it's the number. So now we have to write the conclusion. But when I write the conclusion, I just basically write their sentence from the question and I just change it to an answer. So by MVT, because we did this algebra slope and it equals -1, that's it. Calculus slope equals algebra slope. The algebra slope was -1, so we're good to go. So what I'm going to do to finish it off, to conclude, I'm just going to write their sentence. So by MVT, blah, 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 blah. Then, maybe we should put a because here. But because the algebra slope equals -1, then, and we're just going to rewrite this. F prime of c equals -1 for some c in between x is equal to -1 and x is equal to 3. And that's the first question. This is how you do MVT questions. You find algebra slope and verify it's the number they want, and then you write their sentence. Unfortunately though, again, there's an additional question, finding the c. When you have these algebra sort of questions, you're going to be able actually to find a c. It's not going to be too bad. All we're going to do is we're going to take the derivative and set it equal to the number we want, which is -1. So again, though, be wary that this is outside of the mean value theorem process. This is an additional question after mean value theorem, where mean value theorem is only used for calculus slope equals algebra slope somewhere, and this additional question actually finds that somewhere. But mean value theorem is an existence theorem, so it actually doesn't state where that actual number is. In this case, because we're able to take derivatives, we can actually find that number. So it's a pretty easy thing. All you do is you're going to take the derivative, 2x minus 3. You're going to set it equal to -1, and you're going to solve. So it looks like 2x is equal to 2 by adding the 3 over, so x is equal to 1. Keep in mind that sometimes questions are very, very tricky. Mean value theorem guarantees a number within the interval strictly. So for example, if we had somehow gotten -1 and 1, the answer choice that we would want to choose is just 1 only. There would be -1 and 1 as an answer choice, but mean value theorem guarantees the value that there's going to be a number strictly within the interval and not the endpoints itself. But again, this is how you do an MVT question. Find algebra slope, verify it's the number you want, and then write your sentence. And potentially you might be actually finding the C by taking a derivative. But again, throughout these questions, on the free response questions in particular, usually MVT or IVT is not found using these functions. Usually it's through a table. So let's practice with tables. So let me erase this. So let's draw a very, very simple table. Let's say we have a particle to bring particle motion into the mix. So we have a particle whose velocity is given by the table below. So let's say we have this pretty simple table. We're just going to have the numbers 1 and 4 in the table. Then we're going to have the velocities. So what do I want my velocities to be? Well, I'm going to first choose, let's say, I want, let's say 6 and 0. So those are going to be my velocities. And it's going to be a two-part question. The first part is going to be show that v of t equals 5 for some t in between 1 and 4. And then my next question is going to be show that, let's erase this, show that a of t, meaning the acceleration, equals 2 for some t and 4. And you don't have to find the t's actually. So you have this table, you have this business of show that, or why must there exist, or must this happen? And this is an MVT or IVT question. So it looks like we're going to have one IVT question, one MVT question. That's perfectly fine. So let's first try to recognize which one is IVT and which one is MVT. Because once we recognize that, the work itself is going to be very minimal because we have this table. We don't actually have to find values. So again, what you do is you focus on the function. If the function and the question sort of match, then it's usually IVT. If the function and the question is the derivative of that function in the table, that's probably MVT, because MVT is remembered by the phrase calculus slope equals algebra slope. So in this case, because velocity matches velocity, this part 1 will be IVT, and because velocity's derivative is acceleration, this second part is going to be MVT. So let's practice that. So the first one's going to be IVT, so by IVT. Remember that the work of IVT is very, very small. All we're going to say is that 5 is in between the y values that we want. So it's going to be because 5 is in between the y values of this function. So I like to write v of 1, which is equal to 0, and v of 4, which is equal to 6. So keep in mind, I'm saying that 5 is in between these two y values. Sometimes they're a little bit tricky, and this 5 would be able to be in between the x values or the t values as well, but you want to focus on the y value. So because 5 is in between the y values, v of 1 of 0 and v of 4, which is 6, and then that's all the work that you need to do. Again, it's kind of weird because you're not doing very much work, so you can just state the theorem. So there is a c. So there is a t, where t is in between 1 and 4, such that v of t equals 5. Now let's do the MVT question. Again, I know it's MVT because this quantity is the derivative of the quantity in the table. So now we're doing MVT. So by MVT, and when I do MVT, I like to just immediately find the derivative. So because not the derivative, the algebra slope, sorry. It's calculus slope equals algebra slope. You're not ever actually finding the calculus slope, you're just finding the algebra slope and verifying it's the number you want. So in this case, it's going to be v of 4 minus v of 1 over 4 minus 1, which is going to be 6 over 3. And obviously 6 over 3 is 2. So then we can just start writing the answer, just like before. So in both cases, this because clause is my work, and then afterwards it's just me repeating their question in terms of an answer. So because the calculus slope equals the algebra slope, there is a t. So there is a t where t is in between 1 and 4, such that a of t, remember, which is v prime of t, equals the number you want, which is 2 in this case. Keeping in mind that for IVT, you need to show a numbers in between, so there's a lot of variance. For example, the question wouldn't have changed if this number had been 2 instead, but for MVT, the number has to be exactly the algebra slope. So we were lucky here, the algebra slope was indeed 2. But that's how you do MVT or IVT questions. Hopefully you have a good idea. Remember that IVT or MVT questions are used for things that are pretty general. You're not actually finding the values. So just when the words show that, or why must there exist, I know it's an MVT or IVT question. IVT is when the function matches the one in the table. MVT is when it's the derivative. For IVT, all you do is you say that the y value that you want is in between the y value of the endpoints. So in this case, 5 is in between 0 and 6, so that thing exists. For MVT, you find the algebra slope and you verify it's the number you want. In either case, you write by IVT or by MVT because your work, and then afterwards you can just write, then there is a time, whatever you wanted the time to be. The restructuring of the question as part of the answer for your conclusion. But that's how you do that. Let's do another table just to practice a little bit of IVT and MVT questions, and let's see how sometimes it's a little bit trickier than what we're sort of laying it out to be. So let me erase this. So my next question is going to be this table right here. Let's try to draw the table first. So it's going to be x, f, and f prime values. And there's going to be 3 values in this table. So my table isn't very great. Let me restart drawing my table. So table, this isn't better. X, f of x, f prime of x values. These can be random numbers. Basically, we're going to have 2, 4, and 8. Then we're going to have 3, let's say 0, and we actually need something that works. So we're going to have -4, and then finally we're going to have 1, 5, and 2. So again, what we're going to try to do is we're going to try to prove the existence of 3 different things. So my first thing is going to be prove that f of a for some a equals, let's say, 1 for some a in between 2 and 4. Then my next question is going to be prove that f of prime of b equals some number for some b in between 4 and 8. And we want -1. Finally, I'm going to try to prove that f prime of some other number c equals, let's say, 4 for some c in between 2 and 4. So we're going to take these questions individually. There's 3 separate questions for this table. Keep in mind that all of them are, of course, MVT or IVT questions because you're not finding the numbers, you're just showing that numbers exist. Weird worded questions are usually MVT or IVT. So for the first one, what we're going to do is we're going to follow our instincts. Usually a function equals numbers, IVT. Usually a derivative equals numbers, MVT. So in this case, we're going to do IVT. So we're going to start off trying to say this spell. So let's just start off the answer right here. By IVT, because Then you show your work, which isn't that much, but it's still work. All we're gonna say is that 1 is in between the y values of the interval between 2 and 4. So keep in mind, we're focused on 3 and 0. 1 is in between 3 and 0, of course. So let's write that. Because 1 is in between, BTW stands for in between, x is f of 2, which is equal to 0, and f of 4. So I'm not saying it's in between any x values or any f prime values. I'm saying it's always in between the function I care about, which is f. So it's going to be f of 2 and f of 4 equals, sorry, this one is 3, this one's 0. It doesn't matter if the left coordinate has a bigger value as long as 1 is in between these two numbers. So what it's going to say is, by IVT, that's the work, and then we just write the conclusion. So there does exist an A. So there is an A. And I'm just going to use ellipses because you just repeat their sentence. There is an A where f of A equals 1 and A is in between 2 and 4. So a pretty simple IVT question, just like our previous table. IVT questions don't require too much stuff. All you have to do is show that the number they want, the y value that they want, is in between the y values of the x coordinates. So now the next question is probably going to be MVT because it's calculus slope equals an algebra slope, and we have f prime, and that's the general rule of thumb. Keep in mind that when you're finding algebra slope, you're going to be finding algebra slope, of course, of f. So let's do that. So by IVT, or MVT, sorry, because it's calculus slope, what we're going to do is we're going to immediately find some slopes. So it's going to be 4 and 8. Algebra slope says it's f of 8 minus f of 4 over 8 minus 4. So it's going to be f of 8 minus f of 4 over 8 minus 4. We can continue this work on the next line. F of 8 is going to be negative 4 minus 0 over 4. And unlike IVT, you need the number to be exactly the number you want. So luckily, negative 4 minus 0 over 4 is negative 1. So that's the work. We can write comma, and then we can write so there is, and I'm going to be a lazy again, and I'm going to use ellipses. But the thing you would write is there is a B where f prime of b equals negative 1 and b is in between 4 and 8. So that's how you do MVT. Again, just find the algebra slope, verify it's the number you want. Finally though, questions can be pretty tricky, which is this third question right here. So as you can imagine, it is an MVT or IVT question because you're proving something. Then you might think that it's MVT is going to be used for this question because it's calculus slope, but let's just try to find the algebra slope sort of verbally, and you'll see that this question actually is the exception to the rule. MVT is for algebra slopes and calculus slopes when you have derivatives. IVT is when you don't have it. So let's see what the slope is. So if you find the slope just by eyeballing it, notice it'll be 0 minus 3, which is negative 3, over 4 minus 2. Negative 3 halves would be the algebra slope, but of course that is not equal to 4. But we've mentioned that when you do MVT, the algebra slope that you get has to be the number you want because that'll make it equal to the calculus slope. So in this case, we're going to actually do IVT on the derivative itself. So let's see how that works. Because MVT doesn't work. Usually in these questions, either MVT or IVT usually work. We're trying to prove something that's true. Just because MVT doesn't work doesn't mean that IVT doesn't work as well. And then in this case, MVT doesn't work, but IVT works. You should still follow the rule of thumb that MVT usually goes with derivatives, IVT usually goes with functions, but in this case, this is the exception. So let's see the answer to this one. So by IVT, because f prime of c equals 4, remember IVT, you just show that the y value you want, so now we're thinking about this as a y value, 4. You want to show that it's in between certain numbers that you want. It's going to be the y values of the function that you're dealing with. In this case, we're not going to be looking at the f row because we're dealing with a function f prime. We're applying intermediate value theorem to this f prime row. So because 4 is in between f prime of 2, which is 1, and f prime of 4, which is 5, 4 is in between the y values of the correct row. Then, we're going to not be lazy this time, let's just try to write out the full sentence. Then, there is a C, such that, and then once you get good to this step, you're basically home free. You just write the question and just say, and change it to your answer. So usually they ask you to prove something or show something exists. So you just say, this is proven, this does exist. So such that f prime of c equals 4 for some to c in between 2 and 4. So that's how it works. Again, MVT and IVT are pretty tricky concepts, but what you're thinking about is you're thinking about the rules. You first recognize it's an MVT IVT question. Generally, MVT will be going for things where derivative equals a number. IVT is where the function equals a number. For IVT, there's not much work required. All you do is you show that the y value that they want is in between the y value that's in question. Even when you're doing it in the weird case, the y value that we want is in between the y values of the endpoints of the function that we're looking at. When you do MVT, you just show that a calculus slope equals algebra slope. So what you do is you find algebra slope and verify it's the number you want. And that's how IVT or MVT work. There are certain exceptions where you sort of break a few rules, but it's still the same thing every time. IVT is the y values in between the y value of the endpoints. MVT is calculus slope equals algebra slope. There are some questions that are a little bit weird, worded a little bit differently though. So let's do one last question and then we will be good to go. So we have this. Let's erase this one last time. So what we're going to do is we're going to take another table, one last table. We're going to populate it with random numbers or pseudo-random numbers. We're going to have f of x, we're going to have 2, we're going to have 4, we're going to have 2, and then we're going to have just maybe a really long table now. So not my best table ever drawn. We're going to have 2 and 2 again. No, let's not use 2 and 2. That's kind of lazy. Let's use 5 and 5, and then we can use 6. And then we're just going to put random numbers here. 1, 4, 6, 10, 11, 13. So this is going to be my table, and what's the question is going to be, what's the fewest number of times? Number of times such that f prime of c equals 0, where c is in this interval between 1 and 13. So keep in mind that once I conclude this, just like normal, I'm going to conclude with their question. So my final words are going to be, because of MVT or IVT, I'm going to show my work, and then I'm going to say the fewest number of times is this, where blah, 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 blah. So now what we have to do is we have to determine between MVT or IVT. Looks like this is a pretty standard question. We have a derivative equals a number. This is actually called Rolle's theorem. There's a f prime of c equaling a number is MVT, but the number happens to be 0 a lot of the cases, and if the number is exactly 0, it's called Rolle's theorem. So let's do MVT though. So by MVT, you know it's an MVT or IVT question because it's a little bit of a weird question. They're not actually asking me to find the number of times, or they're not actually asking me to find the actual zeros of this derivative. They're actually just asking me to find how many times this occurs. So keep in mind that 0 is a very special number because it's very easy to find algebra slopes from any single pair of columns in this table. When you do algebra slopes of other things, it's going to be harder, y2 minus y1 over x2 minus x1. But algebra slopes equaling 0 is very convenient because the y values are the same. So the answer in this case is going to be 2 times. And let me try to argue why it's 2 times. Notice that if you found the slopes between this 2 columns, again, the slope is going to be 0 because it's y2 minus y1 over x2 minus x1, but y2 and y1 are the same number. So it's going to be 0 over a number, which is 0. But there's going to be another pair of columns that also give you slope 0, which are going to be these 2 columns. They don't have to be adjacent, basically, or consecutive. So it's going to be 2 minus 2 over 6 minus 1. That's 0 as well. So the answer is 2, and we're going to employ MVT twice. Because MVT, we just want to show that both of these slopes are 0, but of course they're 0 because they have the same y value. So because f of 6 minus f of 1 over 6 minus 1, that's 2 minus 2 over 4, that's 0. And we can do the same thing for these 2 columns. F of 13 minus f of 11 over 13 minus 11, that's 5 minus 5 over 2, that's also 0. Then we can conclude just like normal. So there are 2 times. There are at least 2 times. Could be more, but we know at least it's 2 times. Such that f prime of c equals 0, and c is in between this interval. So that's how you do MVT or IVT questions. Again, you should expect them on the table free response question. So we have a lot of suggestions now that this video is over. Just remember your basic sort of strategy. MVT is calculus slope equals algebra slope, so it usually involves questions involving f prime. IVT is you show that a y value is in between the y value of the endpoints. Of course, MBT and IVT, even after this long video, is still a pretty tricky concept. So if you want more practice with MBT or IVT, I'm going to link our Girls Teach Calculus video in the description of this video, just like normal, where one of my former students practices several MBT or IVT questions. So she states MBT or IVT, she practices questions where the function is explicitly given, then she practices several table questions, even some exception questions. So if you are having trouble with MBT or IVT, be sure to check out that video. But MBT or IVT are in the table free response questions most prominently, and we created videos on those as well. So if you look at our table free response question playlist, it's going to be 11 videos, one overview video, and one video going from difficulty 1 all the way up to difficulty 10. Those videos often include MBT or IVT questions. So if you practice with those free response questions, not only will you be able to try to recognize MBT or IVT questions, but also how to execute MBT or IVT questions, where IVT is a function values in between the y values of the endpoints, and then MVT is calculus slope equals algebra slope. But whatever you choose to do, if you choose to watch the Girls Teach Calculus video or not, we highly appreciate you watching this video. Give us a like and subscribe if this video was useful for you, but hopefully I'll see you next time as we continue our Advanced Derivative Topics unit. But thanks again for watching, just like normal.